Once again, welcome to Shorten General Interest Seminar. I'm Isaac, one of HPTCs working at York University. The title I will present today is How to Run AI, Artificial Intelligence Programs in Graham. The target audience for this seminar is the one who has interest in AI or deep learning, but don't know where to start, and more importantly, how to start in Compute Canada system. So this seminar should be very basic stuff, but we're not gonna go into deeply to the programming side too much. Rather than I'll talk about how to run sample code in in Compute Canada system. In this seminar, I'll provide a brief introduction to artificial intelligence, particularly deep learning, and different frameworks which are available in Compute Canada using a few specific examples. Even though the title is for Graham server, it is unfortunate now it applies to all servers in Compute Canada because right now Graham server is down for maintenance. However, all the command and environment are shown here should be exactly applied to all servers. Today I'll probably use SBATCH system. Artificial intelligence covers all intelligence demonstrated by machines, and deep learning is a subset of AI. Deep learning is a class of machine learning algorithms in which multi-layers of nonlinear processing units are used for feature extraction and transformation, with each successive layer taking the output from the previous layer as input. The key difference between deep learning versus machine learning stems from the way data is presented to the system. Machine learning algorithms almost always require structured data, which most likely extracted by human, as well, whereas deep learning networks rely on layers of artificial neural networks. So as you see in the diagram, deep learning is a very small subset of the artificial intelligence. As shown in the right side of picture, machine learning and deep learning has a different stage. So you can see definitely there is a feature extraction by human, which means machine learning has one more stage than deep learning. Deep learning has basically input and output as a starting and end point. In between, we have multiple layers to extract the features and classify the information to make an output. A deep neural network, which is called the DNN, is an artificial neural network with multiple layers between the input and output layers. As shown in the example in the slide, approximation and probabilistic inference repeatedly achieved by through these layers. The number of layers gets more and more to handle more factors and approximations. As shown in the diagram, we don't count the input layer as layer. So the example has 3 layers, 2 hidden layers in between input and output layer, and output layer is the last stage of this example. So a family of parametric nonlinear hierarchical representation learning functions which are massively optimized with stochastic gradient descent to encode domain knowledge, or such as domain invariance and stationarity. You can see that there are layers, and we're gonna set more layers to handle more factors or variables, and more nodes. You can see the circles as a node. So more nodes means more factors involved at every layer. Deep neural network copies basic computational unit of a brain, which is called a neuron. The diagram shown here is a cartoon diagram or drawing of a biological neuron, which is left side, and common mathematical model right side. Each neuron, as you see on the left, receives input signals from its dendrites and produces output signals along the axon. Like that, we will think about some mathematical model as a cell body on the right-hand side of the mathematical model. All the inputs actually coming to the cell body and will be weighted by the W0, W1, W2. And then by executing some activation function, we'll try to approximate the result, and it will be delivered like an action on the output side. So biological neuron will be a model for the mathematical model. It's a very similar, how can I say, processing procedures. This basic idea is basically implemented to two big stages. One is training, the other is inference. Given large set of the existing data, the approximation model will be trained repeatedly until it shows a reasonable accuracy of a prediction. And then the model is used to make an inference for real problem data. As you see in the diagram, there is no feature extraction required for this by human. So this is different point from the machine learning concept. So therefore, the more data set to train the model would provide the better prediction. In the schematic diagram, as you see in the slide, the upper part is talking about the training. So we have a large set of the data. We call each one as a batch. And then every time go through this kind of layer models, we call that epoch layer anyway. So those kind of batch will go through these deep neural networks one time to predict what's the image. For example, in this diagram, is it dog or is it human or is it cat? Those kind of image classification will be determined by probabilistic approximation. And then there will be some information will be delivered backward to the model to tune all the parameters for multiplication. Once this training is done, the model will be used to make an inference, as you see in the bottom side of the picture. And then at that time, only 4 of the prediction will be determined using the model for inference. So as I mentioned, the more data set to train the model would provide the better prediction. Therefore, it is also true that training stage requires a lot of memory and intensive computation to deal with that many training set. Then, what can we do with AI or deep learning, those kind of things? This beautiful schematic diagram actually taken from this website I wrote. And as you see, there are bunch of different applications these days. So from image classification to the game AI, many of them are trying to use this concept to increase their performance and accuracy. Supervised learning is close to the machine learning, and unsupervised learning is close to the deep learning idea. And reinforcement learning is pretty much like a deep learning concept with some feedback. So reinforcement learning has been used for many times for game development. And as you can see, a lot of diagnostic problems, prediction problems, and segmentation, lots of applications you can see in the world. What about science field? This is some categorization for what type of science field actually using what type of models using deep learning concept. So high energy physics to the fusion energy, many different science field actually has a different type of questions and problems. So from the classification to the design of experiments, there are many different sectors we can probably apply our deep learning idea into. But overall, as you see, still AI or deep learning has been implemented for analytic kind of problems. As you see, classification, regression, clustering, dimensional reduction, those kind of questions are categorized as analytics. But surrogate models and design of experiments such as simulation or control problems are still yet to go. However, we can definitely see there are some movement to accommodate this deep learning idea to make their simulation or control problem solved. I believe this is kind of nature of deep learning problem. Therefore, it's easy to apply. I mean, deep learning can be easily applied to the analytical problems instead of simulation or control problems. But surprisingly, there are lots of movement to use this one for those kind of difficult field as well. I try to collect a couple of, you know, um, graphs from here and there to show how much deep learning actually getting popularity. So as you see in the first upper right, left upper corner, the share of job requiring AI skills growing a lot. And if you see the right upper corner, and especially job requiring skill in Canada, it's explosively increasing since 2015. And number of startup companies actually using the AI system grows exponentially, and market size grows exponentially. So like this, DL, deep learning or AI, is such a huge movement in many fields. It is actually confirmed by this kind of data for many different scope as well. It's very interesting to see there's such a explosive increase in Canadian job markets regarding with this deep learnings. So deep learning or AI is not only in the field of academia or research anymore. In the real world, they are using this one for their actual business very much. Then why now? Why now DL is very popular? Because AI or artificial intelligence is not a new idea. Someone probably know the famous professor in U of T, Jeffrey Hinton, actually started his famous work in even mid 1980s. However, why now deep learning is very popular? There are briefly big three reasons I can come up with. One is we have lots of data, and because these days data is everywhere, and we have a huge amount of accumulated data in many different fields. So deep learning is possible when you have a certain amount of when you have more than certain amount of data set to have a reasonable result. Therefore, deep learning is now possible with that many such a huge amount of data. And also, there is a second reason I believe is the GPUs. Um, GPU actually accelerates our calculations so much, and especially those kind of data classification or image detection, those kind of things requires a lot of integer operation instead of floating point operation a lot. So GPU shows those kind of field very strong performance as well. So GPU is one of the accelerating factor for growing market in the DL. So as you see in the second graph on the right side, so ImageNet actually is challenging programs actually surveyed how many GPUs actually used to their challenge problems and what is the errors, all the things as you see. The blue line is number of entries using GPUs. So there are lots of companies actually now using GPUs for image detection. And accordingly, the error level actually gets lower and lower. So that actually confirms our understanding. GPU actually help us to make this one possible. Thirdly, obviously, there are a lot of researchers, a lot of people actually working on the numerical side and computational side too. So algorithmic advances, optimizing, regularization, normalization, probability statistics, so many different fields related with computer science and mathematics actually help this kind of field grows so popular right now. So now let's talk about more real problem, how to make it work. There are many of deep learning frameworks like computer languages we have here. So Caffe, TensorFlow, PyTorch, Microsoft CNTK, or ChainENN, and Julia, and MXNet. Oh, by the way, we have another upcoming webinar 2 weeks later about the Julia. So please be aware about it. And even though we have lots of frameworks available in the world, but I just want to focus on TensorFlow and PyTorch today. TensorFlow, the most widely used framework open sourced by Google. So it replaced Google's Disbrief framework, and it runs on almost all architectures: CPU, GPU, TPU, which is Tensor Processor Unit, and even mobile phones. And it has a define and run type of programming idea. So you have to define the model first, and you have to run your model later. And however, in version 2, recently released last year, has a define by run, which is whenever you have a data, you define the problem and then run it. Component called eager execution actually included in version 2. As you see in my black picture, I actually listed all the available TensorFlow wheels. Wheels is kind of distribution offered by Compute Canada for Python API. So TensorFlow CPU, TensorFlow GPU and Estimator, and Tensorboard, those are all available in our systems. So we're going to use that pretty soon. And PyTorch, yes, PyTorch. It is rapidly growing in research community for deep learning framework, which is developed by Facebook. It's pretty much like a Python adaptation of Torch. Torch was a previous version of PyTorch. And Caffe 2, there was a separate framework. Caffe 2 existed before, but it is now merged to the PyTorch. And it has defined by runtime for the neural networks. And it is easy. It has easy expressions, and it is kind of easier than TensorFlow to use it. As you see in our system, we have lots of Torch wheels, so we can easily install that and use that in our virtual environment. Here is a quick comparison between PyTorch and TensorFlow. There are pros and cons, easy to use, large community. PyTorch is pretty much like intuitive, and most important part is dynamic graphing, which is defined by runtime of the programming. But TensorFlow actually moving on the dynamic graphs as well by adapting eager execution. However, TensorFlow has a Tensorboard. I'm going to show you later. Visualizing is beautiful. PyTorch is growing, but still relatively smaller than the TensorFlow community. So here's some definition for the define by run and define and run. So you can probably see that. Think about what's the kind of difference later. And this is kind of trend in deep learning frameworks right now, based on GitHub stars. As you see, TensorFlow is absolutely dominant in the number of GitHub stars right now. However, if you look at the others except TensorFlow, PyTorch actually growing so rapidly since 2017. So these days, a lot of people actually pay attention about PyTorch a lot in especially research community because it's kind of easier to use it. But still, TensorFlow has lots of applications and also has widely used for different type of architectures, which sometimes useful or required for commercial packages. So this is big picture how to use the frameworks. So you need application at the beginning, and that application must run on the framework, Caffe, TensorFlow, or PyTorch, those kind of things. And every time when you use PyTorch or TensorFlow, those kind of things, you have to probably use NumPy or those kind of mathematical libraries as well. So you need to have some mathematical core libraries which is adapted and optimized for each architectures. And also, you have many different architectures. In these days, there are some architectures, which is CPU or GPU, those kind of things, is is purely targeted for the deep learning frameworks only. So there are a bunch of different types of um, kind of different name of the brand's architectures as well. But we're going to focus on GPU today, and then all the kind of frameworks. We're going to focus on TensorFlow and PyTorch only here, and CUDA DNN library as well. So once again, NVIDIA GPUs are very main dominant field in GPU sections for top 500 supercomputers. Volta and Pascal, those kind of things are very popular. We have those kind of things. I'm going to show you a chart pretty soon. But before I'm talking about more on all the available resources in Compute Canada, I just want to emphasize our T4 Turing GPU node in Graham. This is our latest addition to the Graham server. It has 8 tensor cores for each T4 GPU card, and it has a pretty nice performance. And good thing is, it is not many people know we have a new addition to Graham, which is T4 Turing. So if you're gonna use it right now, you may have less waiting time on this kind of things. T4 Turing GPU chipset is targeted for the DL, as I show you here. So it's very performs really well for those kind of DL machines. So as you see, Graham, SETA, and Beluga, we have GPU nodes. Unfortunately, we don't have any GPU nodes. So you can see each server, Graham, SETA, Beluga, has different type of GPU processors, Pascal Volta, you can see that. And it has a slightly different configurations. So it is recommended to check our Compute Canada wiki pages before you actually submitting your job or submitting any big jobs for GPU cores. So it has some, you need to attach some special augment to submit your job, and there's some CPU GPU ratios, because whenever you run your GPU, you need some extra works like loading the data or writing some data, something like this. So there is some ratio between CPU and GPU actually required. So you need to, even though you need 2 GPUs, you can't say only 2 GPUs are assigned for DL machines. So you have to have a certain amount of the CPU to deal with those kind of extra jobs to handle that. I'm going to show you how to do this soon. Okay, virtual environment. So let me now change my screen to the terminal. This is the terminal I opened for. As you see, this is a SEDAR system. And I already loaded some modules I need to run something. Okay. Okay. Virtual environment. I need to explain virtual environment first. So virtual environment is the, literally virtual environment, so that you can download and install some Python packages or some virtual packages on top of that. So what you need to do, okay, let me start module restore. Let me start from the beginning. So we have the module I have from the beginning. When you log in, you have this kind of modules only. And then I need to load Python first, because Python is the core language to handle this kind of virtual environment, all the things. So I'm going to load it. So if you check it quickly, I do have a Python adaptation here. And then I need to make a virtual environment. So virtual environment, no download, which means I'm not going to download any pre-built packages. And then I need to determine what location you're going to make your environment. So I am going to write down like a TF1, or you can assign home TF1, something like that. Okay, which means I will try to make an environment, and all the configuration will be stored in that directory. So based on the Python version, I'm generating the virtual environment for TensorFlow 1. And then if you list, you can see that there is binary, include library, those kind of environmental information actually stored there. And if you do, there is an activate binary, which will activate my virtual environment. So what I'm gonna do, source tf1 binary activate, and then please look at my terminal information. It will be changed right now. So as you see, my terminal information has been changed. So because I actually entered into the virtual environment right now. Okay, and then I need to update my upgrade no index pip. I need to install my Python package installer. Okay, and then if I check the Python version, this is my environment. And then you can get out of here by deactivating. Not the Control D or not exit, just deactivate. Then you get out of your virtual environment. Okay, and then I want to install. Okay, let me change my slide. This is my virtual environment. So we're gonna install our TensorFlow, PyTorch, those kind of things within this kind of virtual environment. So virtual environment is very important. It's one of the shell or one of the kind of umbrella you need to use for the deep learning applications later. And Python packages available. Wheels, I already showed you this one, so I don't want to repeat that. So what I'm going to do, I will try to install TensorFlow and PyTorch, and I will run CFAR10 dataset deep learning problems, which is available in this website in the computer science department in U of T. And this is kind of basically image identification. So we have only 10 set of the image and 10 classes. So from the airplane to the truck, and this image will be trained and try to predict something. So I just need to get into the virtual environment first. To do so, you just need to do source tf1 and binary, active. And then I need to install TensorFlow because I don't have the module yet. So pip install no index TensorFlow GPU. There are, okay, so there are a bunch of different things, but as you see, there is a TensorFlow CPU, which means you can run your DL program on CPU as well. But I want to run it on the GPU, that's why I'm using this one. So let me get in again quickly and pip install no index TensorFlow GPU. If you do that, it will probably install the GPU, TensorFlows, all the things, and you can get out. I already did it to save some time. So I have different environment, which I made it TF. So if I activate this one, I already have TensorFlow GPUs, so I don't need to install one more time. Let me deactivate first. To do so, let me use interactive mode. So let me move my uh, location for the program. Because you cannot run any interactive mode on home directory, so you have to move to the project or a scratch directory. And I want to run this ResNet Pi, sorry, ResNet CFAR. Yeah, this one. I want to run this code, which is, I will show you more ResNet. This is basically TensorFlow code, as you see that. Tensorboard, TensorFlow, okay, you can see that. I want to run this code in the interactive mode. So let me do briefly. So let me use this one. Should be enough. So I want to open interactive mode under my name, only one GPU and 3 CPUs. Memory is 10 gigabyte and 15 minutes. So I have a node. And then once again, I want to source TF binary active. Now I'm in the virtual environment. Okay. Once again, more ResNet Sci-Fi Pi. This is TensorFlow code. I want to run it. How do I know it? Simply Python ResNet C4 Pi. So it is actually running. Once again, epoch means you go through one-time training with one data set. So I set 10 epoch. So it's actually training the model using the one set at the beginning right now, and then it will continue until 10 times. I'm not going to do that because it takes so much time. So as you see, there are some validity steps. Everything is written. In the meantime, let me use another one. It takes so much time. So if I go to that directory I'm right now running, you can see there is a logs directory will be generated later. And then there's a fit. At the time, all the kind of track information will be stored here. And this information will be used to open the Tensorboard later on. Anyway, I stopped at this one. It's OK. And I can install the PyTorch, the same idea. So you can do, once again, not PyTorch, Torch. So you can see that there is a Torch CPU and Torch GPU as well. So you can also install Torch GPU and CPU and something like that. I already did it in my virtual environment, so I don't need to install Torch one more time. All the details how to install PyTorch or TensorFlow, everything is available in our wiki page as well. So let me simply show you what is the Torch. So I have, okay, I have a PyTorch program here. So this is PyTorch 1. Yeah, the file has this kind of long idea. So as you see, this is Torch region, Torch utils, some Torch syntaxes. You can see that. How to run it? Simple. Just run it. Python Sci4 10. You just need to run this way. Same idea. In the meantime, let me explain different one. Yeah, as you see, already downloaded, verified because I ran this one before. So you can see that it's actually showing some works, what the machine learning, sorry, deep learning program actually working on. In the meantime, let me briefly show you about the TensorFlow, all the things. You can run this job using the batch code as well, batch script as well. So TensorFlow and PyTorch is almost everything is the same. You see that you need to activate your virtual environment, and you have to move it, and just simply Python. Everything is the same. There's nothing different. Only some modules you need for some TensorFlow, or sometimes you don't. And also Tensorboard, this is a fantastic tool to check out your reasons and all the results and the graphs, everything. Briefly, we have a Horvath to run the multiple node simulation. So far, all the information I gave you about the multiple GPU or single GPU for the the deep learning programs. Then how do I run the multi-node GPU program? I'm sorry, deep learning programs on GPUs. Horvath is one of the applications we can use. And then here is some details how to install it, because Horvath is not available as our central stack yet, because we're testing right now. So you need to install Horvath, and then once you have some library, which is NVIDIA Collective Communication Library, Horvath actually using this one and an MPI idea to run multi-node simulations. So you have to install certain modules listed here, and you have to install, once again, NVIDIA Collective Library too. And then you have to set up some environmental setups as well. And then once you open your virtual environment, and you have to install Horvath, which will be successfully installed like this. I just did it yesterday for you guys, so it must work right now. And then this is the SBATCH you can run. And you may see that because we loaded a couple of modules we need. And then source, this kind of activate means we're getting into the virtual environment. And then I move to another directory I need to run. And then I gave some parameters for the NVIDIA Collective libraries. And we run the MPI code basically, right? Srun, Python, and certain code using certain model for the Python. It requires for the model, the code, and batch size and variable update to Horvath. This is the key parameter to multi-node simulations here.